What's going on YouTube? It's Brian with Radical Prep. I'm going to help you out today with the Algebra 1 Common Core test. It was the June 17th, 2015 exam. So I put a link to the actual test in the window below. You can click it, do it at your own pace, and check back with me, or you can follow along right now. I'm going to go through it, hopefully at a quick pace, give you tips and tricks along the way. All right, so let's get this going. Let's start off with number 1 here. This one says, the cost of airing a commercial on a television is modeled by the function C of n equals 110n plus 900, where n is the number of times the commercial aired. So I might underline that, during test day, n, so at least I know what the variable is. N is the number of times it aired. Based on the model, which statement is true? So let's look at one. The commercial cost $0 to produce and $110 per airing up to 100. Well, no, it didn't cost 0 to produce, because no matter what, when you walk in the door there, you're going to pay 900, right? That's a standalone number, so it's just a 900 hanging out there. So you're definitely paying at least $900 just to enter the studio. The commercial costs $110 to produce and $900 each time it is aired. Well, no. Remember, N is the number of times the commercial is aired, and that goes with the 110. So it's $110 each time it's aired. 2 is out. 3, the commercial costs $900 to produce, I like it, and $110 each time it is aired. Yeah, 110N. N is the number of times the commercial is aired. You got to go with 3 in this one, all right? So just a quick tip before I move on, look at the number that stands by itself. You could be going to a shooting range. It costs you, 30x plus 50. Maybe that's $50 to go to the shooting range. But the number by itself is always what it costs you to do the thing, do the event, all right? So a good thing to pay attention to that number. Let's move on. Number 2. Number 2 says, the graph below represents a jogger's speed during the 20-minute jog around the neighborhood, or her 20-minute jog around the neighborhood. I'm just going to move up slightly here so you get the whole thing. Which statement best describes what the jogger was doing during the 9 to 12-minute interval of her jog? Well, what's going on during that interval? First, let's find it. Here's time. There's 9 to 12. And we got a flat line here. What does that flat line represent? Well, this is speed, right? So that means her speed was constant. Her speed isn't changing here. She's got constant speed. And the constant speed was at 6 miles an hour, 6 mph. So we just want an answer that she was going at a constant speed. So number 1, she's standing still. No, that's not what it means. She was increasing her speed. Nope. Decreasing her speed. Nope. What do you know? Number 4, jogging at a constant rate. Right? So just because the line is flat doesn't mean she's not moving, because she is keeping a speed. She's just, steady, 6 miles per hour. Cool. Let's move on. Next one. I want to get you guys through this and make sure you get all the tips and everything you need to do well and pass this course, because I know a lot of you guys watching these probably have to pass. If the area of a rectangle is expressed as x to the 4th minus 9y squared, then the product of the length and the width of the rectangle could be expressed as. All right. First thing I would pay attention to before I start multiplying is, how do I get x to the 4th when you have double bubbles, right? So when you have something like this, don't you normally do x squared times x squared? And if you didn't do that, you could do x to the 3rd times x. But when you multiply x's, you got to add the exponents. So the reason I'm telling you that, and the whole point was, 1 is gone. X times x is x squared. What else is gone? Can you see? 4 is gone. X to the 4th times x is x to the 5th. All right. So the quick way is, I would say, are there any middle terms here? Obviously no, right? There's no middle terms. When does that happen? Well, I'll give you an example. X squared minus 16. Doesn't that turn into x minus 4 and x plus 4? And what if I gave you x squared minus 25? Please tell me you know what that is. X minus 5, x plus 5? Doesn't matter what order they're in. So when you have no middle terms, the signs have to be what? Signs must be opposite. Must be opposite. If there's no middle terms, right? So since I see no middle terms here, no x, y, whatevers, you're going to do, or you're going to get rid of this one. and you're going to pick this one. There's a minus sign, there's a plus sign, and they're both the same expressions. All right, so this is one you need. Signs must be opposite when you have no middle terms. Quick way to do it. Okay. You don't want to be multiplying all those things out. It's just, it takes too long. You could do it on test day. You got enough time with this test, but you know, you'd rather not do that. All right, number 4. Which table represents a function? I love these questions because they're super easy to explain. How do I know I have a function with the graph? You ever do the vertical line test? And if it only hits one point, you got a function. If I gave you a graph like this, something weird like that, this one hits the graph in 3 spots. So this one is not a function. Not a function. Okay? So how do you tell that with situations like this? Well, I'll use number 1 for example. We have 2, 3, and we have 2, 7. So let me just put the information here. Let's say you're graphing and there's 2, there's 3, and there's 7. Okay? So here's 2, 3, here's 2, 7. You do your vertical line test, it hits 2 points. So it's gone. So what happens if you go to this one? There's a point at 0, 0, and there's a point at 0, 1. Well, I'm not going to draw this out again because when you do the vertical line test, what's going to happen? You're going to hit 2 points, right? It's not a function. That's gone. Here's 0, 0. Here's 0, negative 1. That's gone. So when you have the same x but different y's, it's not a function. That's probably the easiest way I can tell you. Same x but different y's. So now look at number 3. No, there's no duplicate x's. This is your good answer. That's it. That's all you got to do. All right. Number 5. Which inequality is represented in the graph below? Well, first thing I would want to know is what is the equation of this line? And I hope you know that back in the day, or hopefully you'll learn that y equals mx plus b, right? And right there, the m is a slope, and the b is the y-intercept. Hopefully you guys know that. So now, quick way to figure out the y-intercept is where it hits the y-axis. It's at 4. So this equation should be y equals some slope plus 4. So now let's go look at our answers here. We've got negative 3 is one of the answers. We're going to cross that out. We've got another negative 3 here. We're going to cross that out. So we only have answer choices 1 and 2, right? Now we're not even going to worry about the slopes here because they gave us both the same slope. All we got to know is if that's our line, which one means all the information to the right. Okay? And that one is greater than. All right? So you should know greater than or equal to. It's greater than or equal to because it's a solid line. If it was a dotted line, it'd be just greater than. But greater than means up, all the information that's up, and all the information that's to the right. Less than, I'll put this greater than is up and to the right. So this is everything to the right or everything above, I guess you could say. Less than or equal, less than is all the information that's left. You could think left, less left, less left, left and lower. Maybe that's a good way to do it. All the L's. Less than is all the information. If it was less than, you'd want this. All the stuff to the left. All right. That's it. That's all you got to do. Super easy. You're going to pass this test. I promise you. Actually, can't guarantee you. So I don't want you guys coming back to me with lawyers. If you keep working hard, you'll do well. Let's put it that way. That sounded corny. Just keep practicing. That's what else can I tell you? Number 6. Mo's farm stand sold a total of 165 pounds of apples and peaches. She sold apples for $1.75 per pound and peaches for $2.50 per pound. If she made $337.50, how many pounds of peaches did she sell? I'm going to solve this the using the answers way. And what I'm going to assume is, I don't know if this is true, I'm going to assume this is the right answer. So here's a strategy to use if you have no idea how to do the problem. How many pounds of peaches did she sell? Pounds of peaches, I'm assuming 65. So 65 pounds, how much were peaches? Sold for $2.50, right? So I got my calculator here somewhere. So 65 times 250 is 162.50. All right. So now, she made, so what am I doing here? Okay, this is how I do it. Sorry, I got lost for a second. She sold 65 pounds of peaches. So if there's a total of 165 pounds, that means there's 100 pounds left over. 100 pounds left over of apples. And apples go for 175. So hopefully, let's do the math here. 100, oh, why am I doing the math? Just move it over 2 decimal places. That's 175.00. Now, so far, these numbers look promising. Here was the peaches. Here was the apples. I should say pounds. So 162.50 plus 175 equals 337.50. Perfect. 337.50. 337.50. So we got lucky. It's nice when it happens. And I kind of picked this number because, I don't know, just eyeballing it, I thought 65 was a good number. I wasn't going to pick one of these small ones. And the nice thing is if you pick a 65 or 100, it works well with the amount of pounds. So that's how you, it's called back solving. That's how you do it. Just pick an answer, assume it's right, and do the math. In this case, we got lucky. So that's cool. All right, number 7. 7 says, Morgan can start wrestling at age 5 in Division 1. He remains in that division until his next odd birthday. When he is required to move up to the next division level. Which graph correctly represents this information? So he starts wrestling at age 5. So you see we got a lot of solid and empty dots here. So he starts wrestling at age 5. It means it's got to be a solid dot at 5. It's got to be filled in. So that's gone, and that's gone right off the bat. Right? Because if he's wrestling at age 5, it should be a solid dot saying he's actually doing it. So now we know at every 2 years, he moves up to the next weight division, right? Every odd birthday. The problem with this graph is this is saying he at 7 years old, he's in Division 1 and he's in Division 2. That doesn't make sense because 2 dots are occupying the same space, almost like the previous problem where I was talking about not being a function. So in a way, this really, it's not a function. It doesn't make sense. And you can see how sometimes when something fails the vertical line test, it doesn't make sense. How can he be Division 1 and Division 2? So this is gone. Let's just make sure this makes sense. He gets to 7, whoop, he goes up to Division 2. He gets to 9, whoop, goes up to Division 3. Makes sense. Choice 1 is your answer. All right, let's move on. Number 8. Hopefully we're making good time here. Which statement is not always true? And I would recommend underlining that. And we'll do it twice. Not always true. The sum of 2 irrational numbers, the sum of 2 rational numbers is rational. Is that always true? Well, they're saying 3 plus 7 is 10, or something like 3/4 plus, I don't know, 9/4. That's 12/4. That's still rational. A rational number is just a fraction that doesn't have infinite decimal places, or a number that can be expressed as a quotient, the more technical way. So this will always be true, I got a feeling. Sometimes these questions are tough because if you're not really math literate or you don't have a lot of experience with math, they're kind of tough to get a feel for. The product of 2 irrational numbers is rational. So is that always true? Let's see. The product of 2 irrational numbers. So an irrational number like radical 2, and let's take radical 3. Let's make it easy. What's radical 2 times radical 3? It's going to be radical 6. That's not always rational, right? It can be certain situations, right? So this is a case where the statement is false. So that's an answer we're looking for. Just to give you an idea, radical 2 times radical 2 gives you radical 4, which does equal 2. And that would make this situation true. The product of 2 irrational numbers is rational. But we also found a situation where it's not always true. That's why we picked choice 2. So we got to go with 2. I'm not even going to test the others because honestly, I don't feel like it. And I think I got the right answer. All right, number 9. The graph of the function f of x equals radical x plus 4 is shown below. So what do they want to know? The domain. Okay, so say it with me, guys. Domain is the x values. Domain equals, or I should really say possible x values. So let's look at our answers. This means x's such that line up and down, you're going to just say such that x is greater than 0. Well, no, we've got x's that are in the negative area, so that's gone. We're not really talking about 0 here. They're trying to trick you by picking range questions. Let's look at 3. X's such that x is greater than negative 4. Well, it's got to be greater than or equal to, because this is a solid dot. Solid dot. Fills it in. So this is x such that x is greater than or equal to negative 4, right? Negative 1, 2, 3. That's negative 4. That's the one you want. These are range values. They were trying to trick you because they assumed that you saw it didn't go above 0. So range is, I know this is taking time, but range is, possible y values. All right, cool. Let's move on. Number 10, the zeros of this function. All right, zeros is a fancy way of saying what are the solutions, right? So when you have an equation and it does this, these are your zeros, right? When you have a parabola, wherever it hits the x-axis. So those are zeros or solutions. I don't know if that really helps you for this question, but just for your own information. Okay, let me just erase that. So the zeros and the solutions hit the x-axis. So all we're going to do for this one, do your double bubble. Try and figure it out. That's the best advice I can give you. So I'll actually try and figure it out. How do I get to 30? Well, I can do 6 and 5, right? I can do 6 and 5, but I don't think that's ever going to make 13 when I add up. So I'm not going to go in that direction. I'm going to do, and I can do 10 and 3. I don't think that's going to work. Honestly, I think it's going to be 15 and 2. And you can tell actually, I wasted a little bit of time because you can see from your answers here that's either 15 and 2 or 10 and 3. So I might as well, let's try 15 and 2. I gotta make it to negative 30. So one of these has to be negative, and it's going to be the negative 15 because that's bigger than, here, I'll just do it out. First, outer, negative 15x, inner, 2x, last, negative 30. I'm just using FOIL. That's all I did there. First, outer, inner, last. And negative 15 and 2 is negative 13x minus 30. And you get the answer. So our answers are 15 and negative 2. Choice 4. Why was it 15 and negative 2? Well, if you set this equal to 0, like I told you before, you just take the opposites. So if x plus 2 equals 0, x is negative 2. If x minus 15 is 0, it's the opposite. It's 15. So your answers are x equals negative 2. Negative 2. 15. You're done. Move on. Hopefully we're making good time here. You got 2 more. Joey enlarged a 3-inch by 5-inch photograph on a copy machine. He enlarged it 4 times. The table below shows the area of the photograph after each enlargement. All right, so the question is, what is the average rate of change in the area from the original photograph to the 4th enlargement to the nearest 10th? All right, let's see here. Original, so we have 4 enlargements. So I would want to know, to find the average rate of change, would be the change in size divided by the number of changes. So change in size, I'm going to put at, we went from 15 to 36.6. So 36.6 minus 15 all over. We said there were 4 enlargements, right? So that's really going to be, that's 15 plus 6.6. So that's 21.6. 21.6 divided by 4. And what is that? 21.6 divided by 4. 5.4. Oh, there you go. Choice 3. You're done. Number 12. Let me move this up a little bit. Okay. Which equations represent the graph below? So we've got 3 different equations. I don't know if I know a trick to figuring this out, I'll be honest. I might just have to test points. And maybe you guys could give me a simpler way to do this, but you got plenty of time on the test, so maybe I'll just do it like this. I'm going to pick a few points out. I've got 3, 0. That looks like 1, 0. And that looks like -2, 0. So what I'm basically doing here is saying when x is -2 and I plug in, my y should be 0. So let's use that one. It works for this one, right? When x is -2, because -2 plus 2 is 0. So 0 times anything is 0. So -2, 0 works for that one. Let me do this. I don't know if that's the best one. Let's see. -2. Well, let's try it for the next example. It's not going to work in the first thing, right? Because that's going to be -2 minus 3. But hopefully it makes this expression 0. -2 squared is 4, minus 2 minus 2. Well, it works for this one because 4 minus 2 minus 2 is 0. So that will give you a y value of 0. So far this point is not helping me that much. What about number 3? There's got to be an easier way to do this. Number 3. Well, -2 squared is 4. -2 times -5 is 10, plus 10 minus 6. So that's what's nice about that one. That one doesn't work. So I can get rid of this one. Okay. Right? -2 squared is 4. -2 times 5 is 10. Well, yeah. So I tested this point, and it doesn't make y equals 0 for number 3. Right? When you plug in this one to number 3. So 3 is gone. Let's test number 1. All right. When x is 1, y should be 0. X is 1. We'll plug in here. 1 squared is 1 minus 4 minus 12. Oh no, that's not the case. Yeah. That doesn't work. So already when I test this point, right, and I put 1 in here, it's just going to be 1 plus 2. So 1 minus 4 minus 12. Yeah, this is gone. It's got to be choice number 2 by default. So listen, I don't know if that was the best explanation. You guys might have a better way to do that one. I'm doing this off the cuff here, but the strategy does work, so you got to go with the answer that's just number 2. So let me circle that one. Just number 2. That's it. So listen, keep practicing. I'm going to do more videos. Click on the next one so you can see me finish this test, and I'll definitely help you to passing this exam or doing well, whichever one you need. Take care, guys.